Welcome to the review and preview problems 8105 to 8111 in the CCG book. 8105 says a regular hexagon with a side length of 4 has the same area as a square. What is the length of the side of the square? Explain how you know. So we know that they both have the same area. So if our hexagon has a side length of 4, the first thing we need to find is the area of our regular polynomial. So I know that my hexagon has 6 sides, which also has 6 smaller triangles inside of it. I know that I can find the area of a triangle by 1/2 base times height. I know the base of my triangle, but I don't yet know the height. I do know that a circle is 360 degrees, and if I divide 360 by the 6 sides that my polygon has, I can tell that one of my central angles is 60 degrees. I then can use some right triangle trig. Half of 60 degrees is 30. So I know that this angle is 30 degrees. I know that half of 4 is 2. And then if I am looking for my height in order to find my triangle, I am looking for my adjacent side. So the tangent uses opposite. Tangent of 30 degrees uses my opposite side of 2 over my adjacent side, which I'm looking for. I need to use my inverse operations to move my a out of the denominator. So I have a times the tangent of 30 is equal to 2. Divide by the tangent of 30. Remember, your calculator needs to be in degrees, so if you get a weird number, make sure it's in degrees. And you get 3.46. This height of this triangle is also called the apothem when we are talking about polygons. So if we take 3.46 times 4 and divide that by 2, that will give us our area of our triangle. And then we need to take that area of our triangle and multiply that by 6 because we have 6 of those triangles. So the area of our triangle is 6.92 units squared. But we have 6 triangles. So we need to take that, multiply it by 6, which tells us the area of our hexagon is 41.52 units squared. It then asks me, what is one side of the square? Well, if I know the area of my hexagon is 41.52 units, I know the area of a square is equal to the base times the height. In a square, both sides are the same. So I can take the square root of 41.52, and by taking the square root of that number, that will give me the side length of my square, which is approximately 6.44 units is the side length of our square. (8-106) says use what you know about similar figures to complete the following task. Find the area and the perimeter of the trapezoid below. When we look at perimeter, we want to add up all of our sides. If this side of our trapezoid is 5, this side opposite is also 5. So 13 plus 10 plus 8 gives us our perimeter of our trapezoid. So you would assume that this adds up to 31. However, you need to be really careful because they did not say this was an isosceles trapezoid, so you cannot assume that this side is 5. We need to use the information they gave us. They told us the hypotenuse of this triangle is 5. The height of this triangle is 4. So if we use the Pythagorean theorem to find this missing piece right here, 25 minus 16 gives us 9, and the square root of 9 would tell us that this side of our triangle is 3. We know that this internal piece right here is 8, and then we need to find what our hypotenuse of our other triangle is. We can assume that this is a rectangle and this distance is 4. That is okay. We also can subtract 3 from 13 and 8 from 13, and we know that this distance or base of this triangle is 2. We now can use the Pythagorean theorem, 2 squared plus 4 squared, to get our hypotenuse, which gives us 20. So then we need to take the square root of that number, and the square root of 20 is equal to 4.47. So now when we add up all of our sides, 3 plus 8 plus 2 plus 8 plus 5 plus 4.47, we can get our perimeter, which is approximately 30.5 units. It is very important that you label your units when we are finding perimeter and area. When we find the area of this, we can do it a variety of different ways, but the first thing that comes to mind for me is I'm going to find the area of both of my triangles and my rectangle and add them up. I know the area of my blue triangle is the base, which is 2, times 4 divided by 2. I'm going to add that to the area of my rectangle, which is 8 times 4. And then I'm going to add in the area of my final triangle, which is a base of 3 times a height of 4 divided by 2. 8 divided by 2 is 4. 8 times 4 is 32. 12 divided by 2 is 6, and when I add these all up, I get an area of 42 units squared. Question B says, find the area and the perimeter of the trapezoid that is similar to this one, but has been reduced by a linear scale factor of 1/3. So when we think of perimeter, and we want a trapezoid that is reduced by a scale factor of 1/3, we are going to take our perimeter of our larger trapezoid, so 30.5 units, and simply multiply that. Perimeter is linear, one-dimensional, so we can multiply that by 1/3, which gives us a perimeter of approximately 10.2 units. With the area, remember, we're talking about two-dimensional. So when we talked about two-dimensional, we needed to take our linear square factor, and in fact square it, or our linear scale factor, excuse me, and square it. So after we square that, we get 1/9. Then we want to take our current area, which is 42 units squared, Multiply 42 units squared by 1/9, which tells us that the area of our smaller trapezoid is approximately 4.67 units squared. So area is two-dimensional and perimeter is one-dimensional. Question 8-107, an exterior angle of a regular polygon measures 18 degrees. So remember, when we are talking about a polygon, the exterior angles always add up to 360 degrees. So in order to find how many sides, no matter what our polygon it is very similar to finding the central angle, but we can take 360 degrees and divide that by 18, which will tell us the number of sides our polygon has. So our polygon has a total of 20 sides. If the length of the sides of the polygon is 2 units, what is the area of the polygon? Well, we can then find the interior angle of our polygon by taking 180, subtracting our exterior angle, which in this case is 18, which will tell us that the interior angle of our polygon is 162. We also know that if we have 20 sides, our central angle of our polygon is the exact same as our exterior angle, so we are looking at an 18-degree angle here. So they said the side length is 2 units total, so we can say that is 2, and divided in half, we can say this is 1 and 1. So to find our area of our polygon, we need to find our area of our triangle. We know that half of 18 is 9 degrees. If we know that this base is 1, we can use our tangent function. The tangent of 9 degrees is equal to our opposite side over our adjacent side, which is the height of our triangle we're looking for. So using inverse operations, we multiply our a over a cancels out. A times the tangent of 9 degrees equals 1. We need to divide by the tangent of 9 degrees. So when we take 1 divided by the tangent of 9 degrees, we get 6.31 as the height of our triangle. So to find the area of our triangle, we do base times height divided by 2. So 2 times 6.31 divided by 2 tells us that the area of this whole triangle is approximately 6.31 units squared. But they asked us for the area of our polygon. So we know that it has 20 sides, so we're going to take 6.31 and multiply that by our sides of 20. So 6.31 times 20 tells us that the area of our polygon is approximately 126.2 units squared. 8-108 says find the missing angles in each problem below using the geometric relationship shown in the figure below. Be sure to write down the conjecture that justifies each calculation. Remember that each part is a separate problem. So let's look at part A first. Part A tells us, and I'm going to do all the work for part A in pink. Part A tells us that angle D is 110 degrees. And K is equal to 5x minus 20 degrees. Write an equation to solve for x. So the first thing that I want to do is I want to start filling in all of my missing pieces. So I know that these two angles are vertical angles. So this angle is also 110 degrees. I know that this angle is a straight line, so A plus B should equal 180. So I can tell that angle B should be 70 degrees. So angle A and angle D are vertical angles. Angle C and angle B are also vertical angles. Angle C and D, A and B, and C and D are supplementary angles, so they equal 180 degrees. So D and K are alternate interior angles of two parallel lines. So we can set D equal to K. So we can set up our equation. D is 110 degrees. K is 5x minus 20. We can use our inverse operations. So plus 20 plus 20 gives us 130 degrees is equal to 5x. Divide by 5. And when we divide by 5, we get x is equal to 26 degrees. If I look at letter B, it says B is 4x minus 11. So I'm going to do letter B in purple down here at the bottom. And it says that letter N is x plus 26 degrees. Write an equation and solve for x. Then find the measure of angle N. So be really careful that this is asking us to solve for x, and it's also asking us to re-plug in our value of x to solve for the measure of angle N. So looking at these parallel lines, I know that B and M, angle B and angle M, are corresponding angles. So I can say that M is 4x minus 11 degrees. I then know that angle M and angle M, angle N and angle M, are supplementary angles, so they equal 180 degrees. So I can set up my equation, 4x minus 11 plus x plus 26 equals 180. I then can combine my like terms and solve for x. The inverse of subtracting 15 is adding 15. So I get 5x is equal to 195. And when I take 195 and I divide by 5, I get x is equal to 39. However, remember, they asked us to solve for the measure of angle N. So when we solve for the measure of angle N, we need to plug 39 degrees back into our actual equation. And when we plug 39 degrees back in, we get 65 degrees. However, you need to be really careful because when you combined negative 11 and positive 26, you should end up with a positive 15. So the inverse of positive 15 is actually negative 15. So you should have subtracted 15 from 180. So it's definitely okay to make mistakes, but you need to look back at your work and make sure you didn't make them or correct them if you did. So our x is actually 33 degrees. So not 39 because of that little mathematical mistake we made. So when we plug 33 degrees back in to find the measure of angle N, 33 degrees plus 26 degrees, tells us that angle N is equal to 59 degrees. So be really careful when you're adding and subtracting that you are using the appropriate sign. 8-109. Ronaldo has a stack of blocks on his desk, as shown below. If his stack of blocks is too wide, too long, and too tall, how many blocks are in his stack? Well, looking at the picture, if we have 4 on top, we assume that there's 4 below it, so we can say that there is 8 blocks. What if his stack instead is 3 blocks wide, 3 blocks long, and 2 blocks tall? So if we extend 1 additional block long, 1 additional block wide, and leave our height the same, how many blocks would we have? Well, looking at our picture, this would leave me 9 blocks on top, which the bottom should have 9 blocks below it, which would be 18 blocks. What if his stack contained 99 blocks, is 3 blocks tall, X blocks long, and Y blocks wide? What could X and Y be? Well, if I have 99 blocks total, and I have 3 blocks tall, I would need to multiply my blocks long by my blocks wide. So using inverse operations, I could divide by 3. So I would have yx equals 33. So my number of blocks would have to be 2 numbers that multiply together to get 33. So the factors of 33 would be 1 and 33, 3 and 11. So if I made a table to notate how many X blocks and how many Y blocks we could have a combination of 4 different things. So X could be 1, Y could be 33, X could be 3, Y could be 11, X could be 33, Y could be 1, X could be 11, and Y could be 33. So looking back above, if I have 2 blocks wide, 2 blocks long, and 2 blocks tall, I notice that 2 times 2 times 2 gave me 8. My length times my width times my height gave me my 3-dimensional figure. Krista is trying to solve for x in the triangle below. What equation would Krista write? So if Krista is trying to solve for x, I notice we are working with a right triangle. Across from my right triangle is my hypotenuse. The side next to my angle is my adjacent side, and the side across from that angle is the opposite side. So I think back to my right triangle trig, my SOHCAHTOA, and cosine uses the adjacent and the hypotenuse. So if I take the cosine of 58.5 degrees, it equals my adjacent side over my hypotenuse. I then want to use my inverse operations to solve for A. So 7 times the cosine of 58 degrees would tell me A is equal to approximately 3.66 units long. Krista does not have a calculator though, but she remembers something funny her friend Juanisha told her. Juanisha's favorite sine ratio is sine of 31.5, which is about 0.522, because 5 divided by 22 is Juanisha's birthday. Without a calculator, use Juanisha's favorite ratio to solve your equation from part A. So because sine and cosine are inverses of each other, the sine of 31.5 degrees is equivalent to the cosine of 58.5 degrees. I also could figure that out by subtracting 58.5 from 90 and noticing that I'm working with 31.5 degrees. The sine is opposite, which for my purple would make this my opposite side for this angle, and this my adjacent side. So if I take the sine of 31.5 degrees and say it's equal to my x over my 7, you can see that I am still solving the same problem. So using my inverse operations, I'm going to take 7 times what she remembers, 0.522, which is going to get me the exact same thing, which is 3.654 units long. And you can see that when we did it with a calculator, we got something very, very close to what Juanisha got using what she had memorized. 8-111 is a multiple choice question. Which type of quadrilateral below does not necessarily have diagonals that bisect each other? So when we look at a square, we know that its diagonals bisect each other. When we look at a rectangle, we know that its sides bisect each other. When we look at a rhombus, we know it has equal sides and its diagonals bisect each other. However, but when we think of a trapezoid, thinking back to an earlier problem when our sides were not the same length, a trapezoid does not necessarily bisect each other.